Saxon Algebra 1, Lesson 98. I accidentally wrote 93, but we're actually on 98, and we're going to take that Pythagorean theorem that we just learned about last lesson and put it to good use in a new kind of problem. I'm going to just jump right in and start talking about it. John asks us to find the distance between the points whose coordinates are 4, 2, and -3, -2. Now, in the long run, you don't have to graph these necessarily. Well, it helps to. So for now, we'll be graphing them. So what I'm going to do is I'm going to start by graphing those 2 points. All right. So I'm just improvising graph paper on my regular notebook paper. 4, 2. 1, 2, 3, 4, 1, 2. There's 4, 2. And I'm just going to label that so it's clear. -3, -2. -3, -2. That's down there, right? So John's asking us to find the distance between the two. Well, shoot. How do we do that? I don't know. We can't just count because they're not straight lines, right? We could count somehow, but this line is going in an angle, and that complicates everything. So here's the secret. Here's the secret sauce to doing this problem. What we do is we take this line and we make that the hypotenuse of a right triangle. Now, my gut instinct is to go like this. I go across, and then I come down, and I make a right triangle. I remember learning this, though, and my instinct was to go up. And I was very confused why my teacher went over that like that, because I saw it like this. And here's the good news. Either way will work. If your brain is seeing it like this, and that's the hypotenuse, go for it. My brain is seeing it like this, probably because when we get into trigonometry, this will make more sense. There's some rules there that we have to follow, and I'm just following them now, even though I don't need to. But either way you see the triangle, what I want you to do is draw a right triangle that turns this distance we're trying to find into the hypotenuse. Now, if we can figure out the length of this side and the length of this side, we'll be able to use Pythagorean theorem, right? Which is a squared plus b squared equals c squared. How can we figure out the length of this line? Well, this is a perfectly straight line, so we can just count the units on our graph. This line is 1, 2, 3, 4, 5, 6, 7 units long. And I'm going to call this A, because it's one of my legs, right? It's coming out. How about this side? Can we count this? Yeah, we just go over to the center here. 1, 2, 3, 4. So we'll call this side 4, and we'll label that B. And that allows us to call the hypotenuse C, which is what we want to do anyway, right? These are the legs. This is the hypotenuse. And now we're all set. We're ready to go and solve for this C. So we know that I'm going to square it immediately. That's probably not helpful to you. Let me go slower. 7 squared plus 4 squared equals c squared. Now I'll write out the 49 plus the 16 equals c squared, right? And I now get that c, I'm going to bring that over to this side. C squared equals 65. Now we better check. Now we're going to take the square root of both sides, right? And I want to see if I can simplify this. So let's do a square root, factor tree of this. I'm going to say 5 times, let's see, it's 13. Those are both prime numbers. So there are no pigs that can come out. So I can say that c equals plus or minus square root of 65. No way to simplify. We use our difference of two squares theorem. It was lesson 96 to get from here to here. But now we know there's no minus length of the side. That's not logical. So now we can say c equals the square root of 65. When I stop showing this in-between step in my work, you can stop showing it in your homework. But for now, I want you to show that intermediate step where we reflect on the fact that it could be, algebraically, there could be a second answer that is the minus. Okay, so what were our steps in doing this? The first thing we did was graph the points. Second thing we did was draw the triangle. Remember that the distance between the 2 points is going to be the hypotenuse, right? And then you draw the other 2 sides, the legs, whichever way makes more sense to you. Third thing that we did was we counted to find the sides. Right? There was no magic calculation. I just looked across here and then I went to the axis because that's where I had my hash marks. 1, 2, 3, 4, 5, 6, 7. And then to count this side, I went to this one. 1, 2, 3, 4. Notice that I didn't put numbers on my markers. I don't need them. I just count across. And then our last step was we used the Pythagorean theorem to solve. And that has its own set of steps, right? But we've practiced that well enough. You plug in and then you do the algebra on it. Okay, so that's how we can use Pythagorean theorem to find the distance between 2 points. Let's do another one. And this one is more or less exactly the same. It's example 98.2. Find the distance between the points 3, -4, and -5, 2. We will continue to graph these. And we only need to make sure it's big enough. I need to go up to 5, don't I? That's kind of big. Never make your graphs bigger than they need to be. Okay? No sense in drawing a huge graph when you don't need it. Okay, 3, -4 is down here. +3, -4. And then -5, 1, 2, 3, 4, 5. +2, that would be up here. All right. We're good. Now we draw the line to connect them. And we know that's going to be the hypotenuse. Now we draw a right triangle where that's the hypotenuse. We could go like this. That's perfectly fine. This fits into my eye a little better. All right, so now we've drawn the triangle. I get myself oriented. These are the legs. This is the hypotenuse. Okay, good. I'm going to put a C right there because I know that's what we're trying to find. Okay, now we can count and find our legs. We're going from here to here. 1, 2, 3, 4, 5, 6. So this side is 6. And then we're going across. 1, 2, 3, 4, 5, 6, 7, 8. This side is 8. Beautiful. So now I know. I'm going to write my Pythagorean up here. And I always write this so that I can keep my bearings straight as to which side goes where. I'm going to call 6 my A and 8 my B. So plugging in, I will say 6 squared plus 8 squared equals C squared. Beautiful. This is 36 plus 64 equals C squared. And this is one of my favorites because it ends up being 100 equals C squared. I use difference of two squares theorem to say, and I'm going to bring the C to the left side. C equals 10 plus or minus. And now I can eliminate the minus value and C equals 10. And as I draw that into my diagram and smiley face it, I realize, oh, this is what we talked about last lesson. This is 6, 8, 10. This is a 3, 4, 5 right triangle that has been multiplied by 2, right? 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So that Pythagorean triple idea has come to bear, and we know this is the right answer to this problem. Okay, isn't that good news? We have 2 more problems in this lesson. We're going to shift our topic. I want to tell you this before we go on, though. Later, we're going to find a formula that allows us to take 2 points and find the distance in between them without having to draw the picture and count the way we're doing here. That formula is called the distance formula, which is a really great name because it allows us to find the distance. And the distance formula is based on Pythagorean theorem. So later we're going to take this process and streamline it a little bit using a formula that's based on Pythagorean. It'll all fit together beautifully. Okay, and this next bit is going to be the other part that we need to create the distance formula. We're not doing that today, but we're looking at the 2 pieces that will later come together. Slope formula. Okay, so with slope formula, what we're doing is we're talking about the equation of a line, right? This is our slope. And we're going to explore a formula that allows us to calculate this slope in a new way. The formula looks like this. To find the slope, what we're going to be given is a pair of matching points. And they're going to look like this. They'll both be x and y, but we'll use a little subscript to say this is the first pair, this is the second pair. This is a comma. I'm going to put a dot on it so it looks like a stylized comma. x1 and y1, x2 and y2. We will be given pairs of points like this, and we will use them like this to calculate the slope. Okay, I'm going to show you how to use it, and then I'll explain to you just a little bit about why this makes sense. This is a formula you're going to want to memorize. We're going to use it a zillion times. And I'm going to tell you right now, this formula and our Pythagorean formula these 2 are the 2 pieces that are going to come together later to give us our distance formula. It's a mashup of these 2. So that's why John's putting these 2 pieces together in a lesson, is so that we can get used to the idea that these 2 things go together. Okay, so right now though, we're just using this. Find the slope of the line that passes through these 2 points. And I dare say these are the points that we just graphed in the last problem. No, not quite. He changed the minus sign around. Never mind. Okay, so we don't have to draw a picture for these. All we have to do is label them, and we'll call this one our x1, this one our y1, this one our x2, this one our y2. Spoilers, it does not matter which pair of points are the 1s and which pair of points are the 2s. We could flip it around if we wanted. What does matter is that the first number is called an x, The second number is called a y, and the numbers on the matching pair are the same. We can't have a 1 and a 2, or a 2 and a 1. The numbers have to match each other. We have to use x and y properly, but this can be the number 1 pair or it can be the number 2 pair. It'll all work out in the end. Okay, when we use this formula, it's very important to use buckets. Please, 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 please. Save yourself the drama and use buckets. And I'll tell you why it's important. We very often have negative values and there are minus signs in the formula. That's a recipe for trouble. So please, just do it. M equals, here's my buckets. And now we will fill in. This is a little confusing because we're working so backwardsy. Y2 is minus 2. Y1 is 4. X2 is 5. And X1 is minus 3. Now we can deal with these minus signs. These two work together, so we're at minus 2 on the ladder and we go down 4 more. This is minus 6. And these two go together to make a plus 8. And we can reduce this fraction, so our final answer is minus 3 over 4. Notice how our minus sign is attached to the 6 up here, but I can float it for my final answer. And that is the correct answer. That's the slope of the line that forms between those 2 points. We don't have to graph it, we just use this to calculate. Okay, we have one more of these, and then we're done. Example 98.4. He says, work the last example again, but this time use this point as the first one and this point as the second one. So he's asking us to prove what I told you would be true, and that is that you can use either pair as the 1s and the 2s. All right, fine. So this will become x1, y1. There's our formula. There we've laid them out. I always lay them out like this. I always write which one is which one, because otherwise these problems quickly turn into a mad scrambled mess of x's and y's flying all over the place. Buckets. And now I work carefully. Y2 is 4. Y1 is negative 2. Y2 is minus 3. And y1 is 5. This becomes 6, and this is negative 8. Remember last time we got 6 and 8, but the minus sign was on the top, right? But when we simplify, the slope comes out exactly the same. All right, so there's proof that it doesn't matter which order you label the points, as long as each one is, the x's and y's are used carefully, and one pair of points are the 1s and the other pair of the 2s. You can't scramble the numbers. All right, that is the end of lesson 98. We talked about Pythagorean theorem and slope formula and how later they will come together to make a beautiful thing called the distance formula. Yay! Okay, thank you. Goodbye.